All right, so now we're going to look at our own data and trying to determine the Pearson product moment correlation coefficient, how it's calculated, and thinking about what it should be based on our data. So I've got my y-axis here. My y-axis is going to be cost of raising the child. So cost, and that's in dollars. My x-axis is going to be age, and that's in years. So plot these points. So 3 and then 10,700. So it looks like we're counting by thousands. So 10,700, that's close to 11,000. 6, 11,700, close to 12,000. 9, 12,600. So there's my 10, 11, 12, that's close to 12 and a half. 12 is exactly 1,500, so that's nice. That's one that's right in the cross. And then 15, we've got 16,700, so up here. So looking at these points, it looks like it's a positive correlation, and it looks moderate to strong. So let's see how we actually calculate it. So we go into our calculator, and the first thing we need to do is make sure that our statistics diagnostics are on. So there's two ways to do that. The first, the easiest way is, you go into mode, and those of you with this new operating system, stat diagnostics need to be turned on. Again, if you don't have the new operating system, let me put it on your calculator. But if you don't have it, then the way you get to it is in this catalog. So second 0, and then I need to go down to diagnostic. I can't remember if I can use my alpha D. No, so I have to go down to diagnostic. Your calculator hopefully is faster than mine. So keep going down until you get to diagnostic. All right, down, down, down. Down, down. Eventually we're going to get to D's. All right, diagnostic. All right, diagnostic on. So you get to diagnostic on, you hit enter, and then enter so that it's done. Anytime your calculator is reset, you need to turn these diagnostics back on. So make sure you do that. So either in your mode or the way we just did. So diagnostics on. And then this is a stat calculation. So I'm going to go into stat, and I'm going to go into edit my list. So you can see I've already put in my list. Remember that if you ever want to clear things out, we go up to the top and we hit clear, then enter. So 3, 6, 9, 12, 15. So pause your video, make sure you have all the numbers like they should be. Then I'm going to quit back to my home screen. And I can see here that this is sort of a line, and it's a regression. So what I'm going to do is I'm going to go into my stat calc. And what I'm going to do is a linear regression. I want to see how strong of a line fit that I have. So that's number 4. So X list is list 1. Remember, second 1 gives me L1. My Y list was L2. So if you've put yours in a different place, make sure you do the different numbers. There is no frequency for this one. We always want to store our equation. And that's so that we can look at the graph. So we store our equation. If I go alpha calc, I get my y variable, so I can store this in y1, and then I can calculate. So here, I've got my r values. And we're looking not for the r squared value, but the r value itself. And this indicates a very strong correlation. So not even moderate, very strong, because it's very close to 1. Let's look at the picture of that, because remember we stored our equation. So here's the equation, y equals ax plus b, so y equals 510x plus 8,750. I want to go into y equals, and so I've got this. I want to look at the plots, so I'm going to go second y equals, and I'm going to turn the plots on. So on, and I want different points, X list, Y list, and then I want to go to zoom, and I want a zoom stat number 9. So here's my points, and I can see it is a very strong correlation because 3 of my points look like they're on the line, and then 1 point is very close. This one is off, but not really by that much. So I'm going to drag this over here also. Okay, so we can see that we have, to describe the relationship, my description is this is going to be a strong, linear, positive relationship. And I can say that my R value is approximately 0.982. And that also tells me strong positive.